Welcome to Complexity Made Simple. My name is Paul Allen, and the subject of today's video newsletter, where we're going to talk about project scoping, Six Sigma project scoping. So that's the subject. It's something that I often see, Six Sigma, I often see go wrong, mainly because we're going to use the wrong type of scoping mechanism for the project that we're actually doing. So Six Sigma project scoping, and this is something, as I say, that I often see go wrong, and we try to draw a box around the project, and the box is preventing the answer being found. So we want to try and avoid making mistakes like that. So let's take a look at the type of project scoping that we could have. Now, the first thing to say is this: you could have, so if you think about, I'm going to call this an engineering project, because essentially a Six Sigma project is often technical, world-class technical problem solving. That's what it should be. Six Sigma is brilliant at world-class technical problem solving. That's what it should be used for. That's its strength. So we've got an engineering project, but there are two types of engineering project that you could be doing. So let's look at this. One is where the solution is known, and the other one is research. Okay, so effectively this project is just an implementation project. So for example, if you were just going to build a bridge, so if you were going to build a bridge across so you're going to build a bridge across a river, for example, we know the solution, we've got the design. What's the scope of the project? So if you were building that bridge, I don't know what this thing might look like. If you're building the bridge, then the scope of this thing is effectively to make sure that all of the work is complete, but that elements of the work don't overlap. So for example, someone is maybe working on the roads up to the bridge, and you say, well, the scope of your work is that here's where your bridge finishes, here's where the road starts, etc. You might decide that the scope of the project does not involve putting the top surface on the road across the bridge. Maybe a separate company has been employed to put the top surface all the way down the road, across the bridge, and all the way across on the other side of the new roads that are being built. So in that sense, what you are doing is you're putting a box around the project, and you're saying you work inside that box and you don't go outside of that box. You don't increase your scope. Yeah? Now that's a known solution. Now in Six Sigma terms, what would that look like? That would be something like, we've got a defect rate, but we know that if we implemented a new laser guided measuring system, the defect rate would be fixed. So if that's the case, the solution is known. So, the project would be reduce defect rate by the introduction of a new measurement system. Now this is not a Six Sigma project. Okay, this is not a Six Sigma project. The solution is known. This is just an implementation project. Just implement the solution if you know what the answer is. Now sometimes I get people that come to my classes and they got this type of project already mapped out, and they say, oh yeah, we're gonna do this. Can I do this as a Six Sigma project? No, you have a known solution. And the scope of that would be like a box, and you stay inside the box. Six Sigma, on the other hand, is research. It is a research project. Because you don't know the answer. If you knew the answer, you would have implemented the solution and you wouldn't have a project because you wouldn't have a problem. So Six Sigma, on the other hand, is a research project. Now, scoping a research project is going to be more difficult. It's got to be more flexible. So the sorts of things that you might have, let's say you were making a product, and that you were going to mold it. You were then going to print on the assembly, on the molded parts. So you're going to print them, and finally those parts are going to go into an assembly. So mold of part A, maybe there's a part B. Let's put it up here. Maybe there's a part C. Maybe only part A gets printed. So that one's going in there. And that one is going in there. Okay? So let's say you've got the process that looks like this. The problem you've got is the defect rate with making that project, making that product. The defect rate is too high. Okay, now, scoping the project. First of all, one of the things we want to scope and control is the size. In other words, I'm not sure this is a word, but I'm going to write it. Is the project doable within a 3-month, approximately a 3-month period? That's how long a Six Sigma project normally takes, 3 months. So you want the project to be of a size so that it's doable within 3 months. So if you said fix the defect rate in that lot, I would say, nah, it's not doable. That's not doable. We need to scope the thing down. Okay. So typically, what's the scope going to do? Well, the scope typically is it's going to want to grab a defined, discrete process. So you want to have your hands around the process so that it's a defined piece of machinery or it's a defined group of people doing an assembly. So you want to get your hands around this. What are you trying to find therefore? A simple way to think about this is which process lets me down. So in other words, you would look at the defect rate coming from here, the defect rate coming from here, the defect rate coming from here, and the defect rate coming from here. You look at all the percentages, and if you decide that the defect rate for moulding part B is your biggest priority, then what we're going to do, we're going to prioritize a project here. And that's the first thing we're going to do. We're going to grab that machinery by the scruff of the neck. Now then, scoping. One of the things you've got to be really careful about here, we don't want to draw a box around this thing and say you cannot go outside of the box. What we are dealing with here is physics. Physics is no respecter of drawing boxes around projects and saying you can't go outside of that. So for instance, moulding part B, we're going to have variables. These of course are going to be the route to your solution. Some of them could be settings. So they are chosen by the operator. Some of them could be maintenance routines. They are set and controlled by the maintenance department. some of them could be material specs. Maybe these are controlled by the purchasing department. Okay, what else could be in there? We could have tool tolerances, and let's have a look at tool maintenance. Okay, so all sorts of variables that go to mold B and cause the problem that we've got, the defect rate. Now effectively that's your scope. The scope is the piece of machinery that you've got your hands around. What you don't want to do now is to put a box around this and say, no, there's only certain areas that you could go. So for instance, if you're an engineer, they might say, well, the engineer is allowed to mess with the settings, he's allowed to mess with the material specs, and he's allowed to mess with the tool tolerances and maybe the tooling maintenance. But they might say, you are not allowed to go and mess with the maintenance routines. That's outside your area of responsibility, and therefore it's outside your scope. Now this is physics. Physics doesn't respect scope at all. If that's where your answer lies, you have to be allowed in there to fix whatever it is you need to fix. So the scope of this is that it's a piece of defined machinery, that the scale of the machinery gives you a doable project, but everything else is in scope. If you want to go and see the purchasing department and tell them that they're buying cheap material and that buying cheap material is a serious cause of your problem, you should be allowed to do that. That scope has to be within the scope of the physics that we're dealing with, because we're dealing with physics and we're dealing with research, and research says everything is on the table. Now obviously what we don't want you doing is wandering off down the supply chain trying to look at the suppliers process, maybe the way they prepare the plastic and things like that. That would be outside the scope. So there is a point where you say, well, you have to stop with this project and maybe start another one, or someone else has to start the next project. But typically what you don't want to do is to stop people stepping backwards away from these inputs and saying, oh, I'll go and see the purchasing department about some of the variables. I'll go and see the maintenance department about some of these variables. I'll go and see the tool room about some of these variables. That is all in scope. And the problem sometimes when people scope a project, they scope it like it's a bridge, and they say, no, the project starts here and it finishes here, and you're not allowed outside that box. Well, physics doesn't know that. So don't overscope your project. Scope the project for size, don't scope the project for solutions. And if you do that, you'll have a good Six Sigma project. And when you do a great Six Sigma project, basically, you will make more money.